Hi guys, Mrs. Sentinel here. I'm going to go through midterm review number 1 with you. Figured making a video would probably be a good idea because then we see it online. You can pause, you can relook at it, and hopefully it'll jog your memory about the skills that we needed. So for the first example, going back to marking period 1, we have y equals negative 3x plus 9. We're going to compare that to y equals mx plus b and get our slope and our y-intercept. The slope in this example is negative 3. The y-intercept is going to be 9. So I'm going to start by going to my y-axis, going up 9 units. The b reminds us where to begin. I'm then going to go down 3 and over 1, down 3 and over 1, down 3 and over 1, because my slope of negative 3 tells me down 3 and then over to the right 1. I then connect these with a straight line. I'm going to try to do the best I can here to make it straight. Okay, but you guys are obviously using a ruler or your ID. Now in the next example, this one is not set up in y equals mx plus b form for us. It's not in slope intercept form yet. So I'm going to add 3 to both sides. And that will give me y equals 1/2 x plus 3. Okay, now again comparing it to y equals mx plus b form. It shows us that my m is 1/2. My slope is 1/2 and my y-intercept is 3. So I go to the y-axis, I go up 3 units, then I go up 1 over 2, up 1 over 2, up 1 over 2. Fill in the grid as much as you like. I'm going to put a lot of points on because I can't use a ruler on here. Okay. Connect through, draw it off the grid, arrowheads on both sides. Now going to the next two, in this one we have a horizontal line, y equals 2. So I'm going to go up 2 units on the y. This is telling me the y value must be 2, so y equals 2. And then a horizontal line all the way through. In example number 4, I'm looking at x equals 5. So I go over to the x-axis, I plot at 5, and this is going to be a vertical line going through the grid. This might be something great to put on your study card. You can write that x equals a number is a vertical line and y equals a number is horizontal. It's a great thing to remember and something we often forget. Now going on to the next skill, solving linear equations. Okay, a lot of different ways to do these, so I'm just going to show you one way. Okay, so my first step I'm going to be to add 26 to both sides. You could have chose to add 9p to both sides, but that's going to make an extra step. So I get negative 9p equals 27. I will then divide both sides by negative 9 to isolate the p to get it alone. I get p equals negative 3. I'm going to circle that up as my final answer. Okay, p equals negative 3. In the next example, before I even get started with combining like terms, I have to distribute. So I get negative 2 times 4, which is negative 8. Negative 2 times negative m, which makes 2m. Then the minus 7 and the 5. At this point, I can combine like terms. Negative 8 and negative 7 go together to make negative 15. The 2m and the 5 will just carry down. I am now going to add 15 to both sides. I want to isolate the variable m, so I have to get it alone. 2m equals 20. Then I'll divide both sides by 2, and I get m equals 10. Circle that up. Final answer. Keep going with our solving. Again, this one looks very similar to number 6. I have to distribute first. I'm going to bring down the 9x, then I'll do the negative 3 times the 3x, which makes negative 9x. The negative 3 times the negative 2 will make positive 6. Remember, a negative times a negative makes a positive. I'm then going to combine my like terms. 9x minus 9x is 0x, but 0 times x, I'm going to write it just to kind of show you. This is something we common mistake I see. 0 times x is just 0, so then we have 0 plus 6 equals 4, and 6 equals 4. Now, if you notice, the variables dropped, and you're left with a false statement. This is going to mean no solution, and box up your final answer. Okay, I'm going to pause for a second and just let you get caught up. Now moving on to question number 8. Again, distribute and then combine your like terms. 3 times 4 is 12. 3 times negative y is negative 3y. And that's going to equal 12 minus 5y. I'm going to combine my like terms together, negative 2y and negative 3y, which make negative 5y. Then everything else carries down, plus 12 equals 12 minus 5y. At this point, some of you might be realizing what's happening. You had a true statement there because the left and right side were exactly the same. But if you didn't, let's see what would happen. You would get negative 5y plus 5y, which is 0. So you're left with 12 on the left side. Negative 5y plus 5y is 0, so you're left with 12 on the right side. Your variables cancel, leaving you with a true statement, which means there are infinitely many solutions. Any number you plug in, negatives, positives, zeros, decimals, will work. Okay, box that up. That is your final answer. Okay, it's really important that we're identifying which is the final answer as opposed to supporting work. So circling up that true, that's supporting work, that supports the final answer of infinitely many solutions. Okay. Now in this example, number 9, we're graphing the system of linear inequalities. Okay, so you're going to need to maybe pause the video, go grab some colored pencils, because this is definitely going to be helpful if we have different colors. So we start by going through one by one, and we're going to graph each line and shade each line. So the first inequality, okay, I'm going to mark it in blue, is going to be y less than 5. Y equals is a horizontal line, so I'm going up to 5, doing a horizontal dashed line at 5. When I'm looking through, I have to remember that if it's a less than or a greater than, it's going to be a dashed line. So less than or greater than, that's our dashed. Less than equal to, greater than equal to is going to be our solid line. So then I want everything less than 5. So when I go to my grid, I'm going to shade everything less than 5. So hopefully with your color pencil, it'll look a little prettier than what I'm going to do. Hopefully it'll be enough to kind of see what we're doing here. Okay. Now the next example, y is greater than or equal to negative 6. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. I'm putting a solid line through because of that greater than or equal to. And then I'm going to shade everything above. Okay, so right now, if you look at that middle section in between, okay, kind of like the bowling alley lane, right, that's where our answer is going to overlap for right now, but we have 2 more equations, which is going to make it a little more complicated. So now in the next example, this is not in slope-intercept form, so I have to change it around. I'm going to subtract 2x from both sides first. I get y equals, y is greater than or equal to negative 2x minus 1. I have a slope here of negative 2. I have a y-intercept of negative 1. So I'm going to go down 1 unit to negative 1, because that's where I begin. Hopefully you can see this. Then I'm going to go down 2 and over 1, down 2, over 1, down 2, over 1. Do a couple more in the opposite direction from that y-intercept, just so it's nice and clear for me. This is a greater than or equal to, so I'm going to draw in a straight solid line through my points. Okay. And now it's going to be greater than that line, so I'm going to go to my y-intercept and go above it, which is going to tell me that I'm on this whole side. Okay, so a little hard to see what's going on, but so far that little, it almost looks like a trapezoid. Okay, it is a trapezoid actually. That little section right there is right now where all 3 colors, the gray, the blue, and the pink, are overlapping. And then we'll get one more color into the mix. Okay, this one I'm going to do in like a dark purple. Hopefully we can see the difference there between that. So I have my slope of 1. I have my y-intercept of 3, so I'm going to go up 3 units. And then we're going to go up 1, over 1, up 1, over 1, up 1, over 1. I'm going to go down and back, down and back, down and back. Okay. This is going to be a solid line again because it was a less than or equal to. It's less than, so I'm shading below the line. Okay, so now when I'm looking to see where all 3 of those colors are overlapping, it's going to be in this section right here. I put a nice big S over it. That is my solution set. So any coordinate x, y in that region are going to be solutions to that inequality. Okay. Moving on to the next one, we have inequalities, okay, in 1 variable as opposed to number 9 where there were 2 variables, x and y. Grid, when we just have x's, it's going to be on a number line. So what I'm going to do is I'm going to solve each of these equations separately. I shouldn't call them equations, inequalities separately. So I subtracted 3 from both sides. I divide by 2. When I do these, I treat them almost like they're equations, just being careful to flip that inequality symbol if I'm dividing or multiplying by a negative. So for the first one, I got x less than or equal to 1. Now for this one, I get 4x minus 8 when I distribute, greater than 8. I'm going to add 8 to both sides. I want to isolate that variable x. So I get 4x is greater than 16. Divide each side by 4, and I get x is greater than 4. So in the first statement, it said that x is less than or equal to 1, or x could possibly be bigger than 4. So I'm going to set up my number line. I put 0, -1. I always like a little scale, having some positives, having some negatives. And I like some numbers before and after the values of my inequality statement. So I'm going to go up to 6. So the first one, x is less than or equal to -1. I have a closed circle on 1, because when I'm looking at that inequality symbol, it was or equal to, and I want to go less than 1, so I want to go everything to the left. I then have an open circle at 4, and I go bigger because it was a greater than symbol, so everything to the right. Now the number line is great, but we also like to write it in interval notation. So I think about what's all the way down to the left on the number line, that's -infinity. All the way to the right on the number line is positive infinity. So my interval notation will be -infinity up to 1. Then we're going to union it with the numbers from 4 to infinity. Now, I actually made a little mistake here. I'm going to go back. At 4, it was an open circle, so I need to use and symbolize that with a parenthesis around 4. So let's write a couple notes. When you have your closed circle, it's going to be a bracket. When you have an open circle, it's going to be a parenthesis. Anytime you have plus or minus infinity, though, you always use a parenthesis around that. Okay, so plus or minus infinity always gets the parentheses. An open circle always gets parentheses, and then the closed circle is what gets those brackets. Okay, so let's move on to the next one. The last one is going through the 3 different systems, or 3 different ways of solving a system of equations. So we're looking here at graphing, which is your guys' favorite, elimination, which is one of my favorites, and then substitution. So when you look through our graphing, what we're going to start by doing is graph each of these lines individually. Okay, so we have y equals 5x plus 5. We have a slope of 5 and a y-intercept of 5. So I'm going to go up 5 units. 1, 2, 3, 4, 5. Then I go up 5 and over 1. I'll go down 5 and over 1. Do it one more time. 1, 2, 3, 4, 5 over 1. Okay, graph that in. And in my next example, I had here a slope again of 5 and a b of -5. At this point, we should be noticing that these 2 slopes are the same, which means that we're going to have parallel lines that might be helping you to figure out what the answer to this system is already going to be. But if not, let's get the visual. So I go down 5 here because a -5 is a y-intercept. Then I'm going to go up 5 and over 1, up 5 and over 1, up 5 and over 1, go down 5 and left 1. And I'm going to graph the line in. Okay, yours is going to look a little nicer than mine because you are hopefully using a ruler. But I noticed that these lines are parallel, which I suspected from the fact that the slopes were the same. These lines will never intersect, so there is no points that they have in common. So there is no solution to this system. Now that I know this system has no solution, when I do it using the elimination and substitution method, I should get the same answer. If not, you have to go back and check your work. So for the elimination method, we have to make sure that we have variables canceling out. So if I look, I have a 5 and a 10, I have a -1 and a -2 in front of the variables. So I'm going to try to get the x's to cancel out. So if I have a 10 in the second equation, I would love a -10 in the top equation. So I'm going to multiply that top equation by -2, because when I do that, it creates -10x plus 2y equal to 10. I carry through that bottom equation. Okay. We'll make sure that when you're multiplying through the equation by that value, you're doing every single term even after the equal sign, okay? So you're manipulating that whole equation. Each term needs to get multiplied. So when I look at this one, I'm going to add them up. -10x plus 10x is 0. 2y minus 2y is 0. But 10 plus 10, be careful, is 20. So I get 0 equal to 20, which is a false statement, and that is going to lead us to the conclusion of no solution. If you think back to when we were solving equations in those first couple problem sets, I'm going to go back up and just show you where. Okay, questions number 7 and 8, those ended up with a variable canceling and then true or false statements. This is the same idea there. So this one again is no solution. Last example that we're going to be going through, okay, only one more that we have to do. All right, I'm going to be using a method called substitution. All right, so what I'm going to do, I already have one of the variables isolated. I have y equals negative 5x plus 5, y equals 5x plus 5. And I'm going to substitute that in for the y in the second equation. So I have in that second equation 10x minus 2. I'm going to leave a blank where the y was, and that's equal to 10. I'm then going to take that top equation and plug it in. So instead of y, I'm replacing it with 5x plus 5. They're equivalent to each other. So I'm going to distribute out. I get negative 10x minus 10 equals 10. I'm going to combine like terms. 10x minus 10x is going to be 0. Remember, it's 0x, and 0 times x is 0, so you don't leave the x behind. If you wrote 1x, that would mean that there is 1x there. There are no x's, so write nothing. So you get negative 10 equals 10. That again is a false statement, and that's going to lead us to the same conclusion that those parallel lines did, or that false statement in the second example, or part B of this example, led us to. There is no solution, okay? No points they share in common. So guys, hopefully this served as a really nice reminder and refresher of the marking period 1 skills. Tomorrow in class, you will be getting midterm review number 2. It's going to go through the same type of problems you're solving, your graphing, your systems, your inequalities, and 1 and 2 variables. So hopefully at that point, we're going to be at a really good spot where we know exactly what to do, and we're ready to take that midterm exam. If not, you know where to find me and you know what you can do. Extra help goes a long way.